This video will present you a technique I have developed while working in a project management team of a refinery construction. This method can provide the piping construction workfront to contractors, can save huge amount of man hours and discipline the construction site. A refinery consists of units. For example, Unit 31 is the vacuum distillation unit. Every unit has systems, subsystems, test packages, and isometrics assigned. For example, subsystem 31AD29-1 has 5 test packages, where test package 366 has 3 isometrics assigned, while test pack 58 has 6 isometric assigned. This is the Level 5 certification file submitted by the contractors weekly. In the yellow part are the piping data. We see the columns of units, systems, subsystems, test packages, isometrics, and the priority of construction as given by the commissioning team. The weight of isometrics in kilogram indicates whether it is a small or large diameter piping, and the price in euro of its construction. The progress is measured in percentages from 0 to 100. For engineering reasons, the progress is shown within the ranges A, B, C, and D. In range A, there are prefabrication and erection works from 0 to 60% progress. This includes cutting, beveling and alignment, prefabrication welding, quality control, as well as spool erection and erection welding. In range B, we have the supports and the flange valves installation and welding, quality control on erection welds, and punch listed items clearance for progress from 60 to 85%. In range C is the isometric progress close to hydrotest, and in range D the pre-commissioning activities from 91% to completion. The contractors are paid monthly according to the progress done. For example, this isometric here with 3,000 euro construction price is erected on site, therefore has 50% progress rate. This means that the contractor who installed it has already paid half of its price. All these data are updated weekly by the contractors and inspected and approved by the piping supervisors and superintendents. I'm using these weekly updates to produce this summary progress report. The table that you see on the left is for Unit 31. This unit has 36 systems, 501 test packages, 3,057 isometrics, and 960 tons of piping. The systems and the test packages progress are also given in pie charts. For example, 77.78% of the systems in Unit 31 are in the green range C, progress close to hydrotest. 38.92% of the test packages of the same unit are in the yellow range D, pre-commissioning progress close to completion. The bar charts on the right show the weekly progress of test packages and tonnage in ranges. The gray bars show the current progress and the white bars the progress of previous week. For example, 195 test packages has reached range D, close to completion progress, while 134 test packages has been at this progress range 1 week before. In the same manner, the weekly progress of the test package tonnage can be seen in the graph below. We can see here that low tonnage piping has reached progress close to completion. The same is done for all the units and in total for all the areas in the refinery. The data from the Level 5 certification file can also be extracted in ranges and presented as shown. This is the data from the range A, prefabrication and erection works. We can see the progress of test packages from the highest priority or the other way around. One very common mistake that the contractors make during construction is that they do not consider the priority of systems when they preparing their construction work front. For example, here we can see that a system with relatively high priority 4 has no progress, while a system with low priority 89 has good progress. This method highlights these mistakes, identifies bottlenecks in progress, and the construction workfront is planned accordingly. In order to be able to provide the construction workfront in isometrics, the data are also presented showing the progress rate for each isometric. For example, the construction manager wants to accelerate the construction for isometrics that are close to be hydro-tested. This means that the manager must identify which isometrics have progress between 80 and 85% punch list items clearance. By filtering the data for progress between 80 and 85%, these isometrics are identified. The isometrics are listed according to the highest or lowest priority, as we can see here. And the workfront is then provided from the superintendents to the contractors for construction. This method was implemented on a 1.3 billion euro refinery construction and was very effective. Thank you for watching.